I'm pleased to welcome my valued colleague, Ms. Chandozi Bhattacharya. Chandozi has a master's degree in data engineering and several years of professional experience as a systems engineer. We're looking forward to the presentation with the topic priority-based approach for timely container delivery. Chandozi, the stage is yours.
Thank you, Max, for the nice introduction. Good afternoon, everyone. Today, I am here to introduce the topic of my master thesis that I did at Fraunhofer CML back in 2021. In this study, I tried to investigate if a priority-based approach using simulation and reinforcement learning can be useful for timely container delivery. So we would be covering the following topics today. I would start with an introduction to my topic, followed by a specific objective of the study. Then I would give a description about the simulation scenario that was implemented, followed by modeling with reinforcement learning. And then finally, I would share my results and a conclusion about overview of the whole topic. Yeah. So to start with the introduction. So, maritime shipping holds a major share in the world trade, and it is estimated that about 80% of the goods are transported by sea. There has been an exponential rise in the number of shipping containers in the recent years, and therefore it is needed in order to cope up with the rising demands. It is important for the operations at the container terminals to be more efficient. To ensure stability and smooth functioning of a terminal, it is imperative to conduct all operations within a specified time, and hence my study is regarding the timely delivery of containers. The study gives an overview about how simulation and reinforcement learning can be integrated together and how practical it is to use these methods for logistic-related problems. The approach used here is to prioritize the containers that are to be delivered and observe if the approach is helpful in delivering containers as close to their delivery time as possible. To get into the specifics, the objective of the study is to ensure the timely container delivery by reducing the time difference between planned and actual container pickup times and observe the decisions made by the model. The study will also help to answer the following questions. If it is possible to reduce delayed or early pickup of containers using reinforcement learning, is each priority rule more suited to certain scenarios? And can early or delayed pickups be prevented by using optimum horizontal resources? This figure gives a basic idea of the workflow of a container terminal. Yeah. So for the simulation, discrete event simulation was used. So the idea of the discrete event simulation is to consider a system as a sequence of processes being performed across various entities. A model is represented in form of a process flowchart where each block represents an action being performed on each of these entities. So it starts with a source block where the entities are created and ends with a sink block where the entities are removed from the system. So in a container terminal, there are broadly three operations. The first one is the seaside operation. So here, the source, the ship and container entities are generated. The containers are loaded onto the ship and it moves to the dock area where the containers are unloaded. Thereafter, these containers are carried by the automated guided vehicles from the dock to the storage areas. In the first storage area, the containers are stored randomly, and then they are taken, carried one by one to the next storage area, where it is stored in different location, different stored separately based on their type of hinterland transport, which can be either trucks or trains. Also, here the heavier containers are stored at a lower level and the lighter containers are stored at a upper level. And as soon as the containers are ready to be picked up, the trucks are generated here and they pick up the containers one by one and they are removed from the system. The containers can have several parameters like its carrier, the type of interland transport, which can either be truck or a train, its weight, a planned pickup time, and a location in the second storage area, which is calculated on the basis of its weight. Yeah, next is the modeling with the reinforcement learning. So I would like to give an introduction to reinforcement learning first. So as we know, the supervised and unsupervised learning methods are the most commonly used ones in machine learning. And reinforcement learning is a third paradigm of machine learning where an agent is trained to make sequential decisions with a feedback received from the environment. Here, the current situation is called an environment that an external agents or our model acts upon. The agent has no information about what the best action is going to be and must discover it by a trial and error method and by looking at the rewards received at every iteration. And this is where it differs from the supervised learning because it has no labeled data set where it can know that which is the correct action to choose. Also, it is different from unsupervised learning because there are no hidden patterns in the state and action pairs, and the decision is always taken by observing the rewards gained in different scenarios from its previous experience. It has five basic elements, namely the environment. Environment is a scenario that the agent acts upon, and it is defined by a set of states. So at any given time, the present state of the environment is observed to decide the next action. The agent is the actor that performs these actions. So in our case, it would be the model. And then there is a policy. The policy is basically a mapping of a set of scenarios to a corresponding action. And then there is a reward signal. Reward signal is the reward value that is gained by the agent on taking an action every time at each scenario. It is used to define that how good or bad an action is at a particular scenario. And then finally there is a value function which determines how to optimize our objective. It takes the states as well as rewards into consideration, and the reward and it aims at receiving the highest cumulative reward in a long run. So in our model, PathMind application was used to integrate simulation and reinforcement learning. PathMind is an application that facilitates the combination of simulation and reinforcement learning, and for that, certain parameters are to be defined. So first, it's an observation function. Yeah, the observation function, it states those variables which define the current state of an environment and collects the values for the same. In our model, the observation function is defined by the total number of containers present in a system, the count of idle automatic guided vehicles and count of idle trucks, and the mean square time difference between the planned pickup time of containers and the current model time. The reward variables help to those metrics that help to understand that which are the correct how good the agent is performing in the decision making. Here, the metrics used are the mean wait time of containers at the second storage area and the average square time difference between actual and planned pickup time of containers. The action functions defines that how many actions agent can take. Here, two discrete functions are defined. There are two queue priority rules. One of them is the containers with the nearest due time are prioritized, and whereas in the other, the containers that have waited for the longest period of time were prioritized. The action trigger defines how often an action should be taken. And the reward function, it uses the reward variables to calculate the cumulative reward over the complete training process. The aim is to minimize the container wait time in second storage area and also the gap between the actual and planned pickup times. So after defining these variables, the model was trained on the PathMind application, and these figures show that how the agent, the model has learned to take each of these actions. So the first graph shows the reward that is gained for the action of prioritizing containers with high waiting times. And here we can see that initially the reward score is very low, probably because the agent takes the wrong actions. And eventually it learns to take the correct action. Therefore, there is a rise in the reward score. And finally, it stabilizes because it has found the best action for a particular scenario. A similar, and the next graph shows the reward score for the other action, which is prioritizing the containers with nearest delivery time. It also has a similar trend as that of the previous one. There is an increasing trend in the beginning, and then it stabilizes. However, there are more fluctuations in this one than the previous one, which would indicate that maybe it has not learned this action that well. Yeah. After the model was trained, uh, so this policy was applied back to the same simulation model. And yeah, it was two things were observed. The first one was how the mean square time difference varies with the resource count. So here we can see that the lesser resources lead to delayed pickup of containers as they have to wait longer in the storage area. For example, in case of the 150 containers, it is very high in the beginning, then it reduces with the increase in the number of AGVs, and then again there is an increase after that. So in the beginning, because of the lack of resources, it had to wait for more. And in at the later case, with the increase of resources, if there are too many resources, then also the containers are picked up much earlier than their planned time, so which is also not desired. So to answer my previous question mentioned above previously, yeah, using optimum resources should be showed the best results. Here, like 4 to 5 resources for containers, lower container counts, and like 7 to 8 resources for higher container counts yielded the minimum difference in pickup times. Yeah. And the next observation was how the reinforcement learning chooses different actions and how it varies over different container counts. So when the number of resources is low, then it is clearly visible that the RL agent prioritizes the containers that have waited the most. So less resources leads to more longer waiting times, and hence it is probably an attempt of the RL agent to reduce the delay. But as the number of resources are increased, we can see that the disparity between these priority rules chosen that decreases significantly. Well, the containers do not have to wait as much in presence of more resources, and hence the other action is also favored more. Yeah, so the model has learned to choose the desired action in the first scenario. However, in the opposite situation, yeah, it has just learned to favor the other one more, but not learned it completely. And yeah, this would explain the training result that we saw before, that there were many fluctuations during learning the second action. Yeah, to sum it up, The objective was to compare the difference between actual and planned pickup time of containers in a priority-based setting and a first-in, first-out setting. No fixed pattern could be seen in the metric in either setting. This is probably because the usage of simulation and logistic-related problems require extensive domain knowledge and precise model parameters. It is also difficult to estimate which factors can affect the desired output. However, the model was able to learn successfully which actions to choose in certain scenarios, and the choices were found to be meaningful. No. And also, the study shows that RL has the potential to be used in complex logistic-related problems, and tuning the model parameters better and making it more realistic would help to achieve the same. That was from my side.
Yeah, thank you very much for your interesting presentation and the shared insights into the topic, Shandazi. Yeah, so far we don't have any questions from the audience. I see there was one. Joshua Miller, you have a question, and there's also Yildiz Mert. So let's start with Yildiz Mert. Which reinforcement learning algorithm have you used? Shandazi, did you hear my question?
Yeah. It's called PPO. I forgot the full form of it. I think it is proximal policy optimization of reinforcement learning. Yeah, it's just proximal policy optimization. So this is the algorithm that, this is Pathmind's inbuilt algorithm. So yeah, this cannot be changed in my setting, but definitely some other algorithm could also be used.
Yeah, thank you very much. And there's one more question that I have. You showed us some experiments that you did, and what were like the challenges that you were faced with during these experiments?
Like for me, I think the developing the simulation model was the most challenging part because the terminal operations is a really complex process, and there are so many factors that would affect the desired output. And so like it was kind of difficult to simplify it and choose from them that which factors I want to choose for affecting my desired output.
Yeah, and how can you achieve to get a better performance for these models?
Yeah, so mine was a very simplified one. So, I mean, definitely improvements can be made on this. So for simplicity reasons, I did not consider a lot of parameters. For example, I penalized the early and delayed pickups equally. But ideally, I think the delayed pickups should be penalized more than the early pickups, and that would help the reinforcement learning agent to learn better. And then container rescheduling was not considered. So in my case, when a container was taken from a lower level, then that space was left blank. But ideally, the others, the space is filled by like the others containers in the top should come down. And actually, because when the trucks are picking up the containers, it takes more time to pick up containers that are at a lower level because it has to move the containers present on the top. And I think this would greatly affect the time that I'm recording, the time between the actual and delayed pickups, the actual planned pickups. Sorry. Yeah.
Yeah, thank you very much. And that brings us already to the end of today's event. Please feel free to contact Chandali with any other questions that you may have after today. You can see her contact details here on this last slide. And on the next slide, like we can see the topic of the next presentation, which will be in 2 weeks on April 14th. It's the topic of automatic speech recognition for maritime radio communication. And yeah, so we will end this presentation now. Have a great weekend and happy Easter. Thank you for your interest in today's presentation, and see you in our next event in 2 weeks. Thank you very much.